In our last lesson, we talked about the reciprocal function of f of x is equal to k over x, where k is a constant. I want to talk about the characteristics of this function and the graph by using 5 over x in this case. Now remember, we learned a couple of things. First, we learned that there is always a horizontal asymptote at the line y is equal to 0, which happens to be the x-axis. The reason that that is true is no matter how big or small I make x, I can never turn this fraction into 0. There's just no way to do it. I do notice, though, the bigger x is, the closer to 0 this is, and the smaller x is, the closer to 0 this is. However, it'll never be able to hit 0. That's the reason we have what's called an asymptote. I also have a vertical asymptote at x equals 0, which is the y-axis, and I have that because I simply cannot plug 0 in place of x because that would be undefined. So what are my points? Well, there's some convenient ones to use. If I plug 1 in for x, I'm going to get 5 for y. And if I plug 5 in for x, I'm going to get 1 for y. So I'm just using the k value. When I plug in 1, I'll get k. When I plug in k, I get 1. So 1, 5 is here. 5, 1 is here. Remember that I could get some points in here, but I know that what I have is a smooth curve that goes through those 2 points with asymptotes of x equals 0 and y equals 0. I know I can't have 0, so I'll plug in some negative numbers, and it's convenient to use -1. That's going to give you negative k, or negative 5 in this case, and negative 5, or negative k, which is going to give you negative 1 in this case. So negative 5, 1, 2, 3, 4, 5, down 1, and over 1, down 1, 2, 3, 4, 5. So once again, I have a smooth curve running through those points with asymptotes of x equals 0 and y equals 0. Now, I want you to notice that there is symmetry to this. If I were to put in the line y equals negative x, then I would have a reflection across this line to give me symmetry. This half matches this half. If I were to draw in the line y equals x and reflect, I actually end up with the exact same graph, and therefore we say that it is a self-inverse. If f of x is equal to 5 over x, then f inverse of x is also equal to 5 over x, because you get just a reflection across there. So self-inverses. All right, the next thing we talked about was, well, what happens if we shift that? And we shifted it up 2 spaces or 3 spaces. We could do however we want. Remember that when g of x, or whatever you've got, is your f of x plus or minus a, that's going to shift it up or down depending on if it's plus or minus. In this case, we're adding 2, so that's going to shift it up 2. So now, instead of a horizontal asymptote at y equals 0, our horizontal asymptote is going to be at y equals 2. Now, since we're just shifting up and not left or right, my vertical asymptote is going to remain the place. It's where this is undefined, which is where x equals 0. So there's my graph now. So how do I get me some points for that graph? Remember, it's still going to be a hyperbola. I know that I'm going to have a section up here and a section down here. And so let's look at the points. If I do 1, 5, and I shift that 2 spaces up, then what I'm going to get is 1, 7. So over 1 up 7 is on the graph. And for my 5, 1, if I shift it up 2 spaces, that's going to be 5, 3. So over 5, 1, 2, 3, 4, 5, up 3. And notice now, when I draw my graph, it doesn't approach 0, it approaches y equals 2. For my other side, I'll just use the other points, -1, -5, shifting 2 spaces up becomes -1, -3. So 1 to the left, 1, 2, 3. And my -5, -1, shifting 2 spaces up becomes -5, +1. So 1, 2, 3, 4, 5, up 1. Now I want you to notice it's going to cross the x-axis this time. Where I didn't have a x or y intercept on the last graph because those were my asymptotes, here I've got a x-intercept. Remember, x-intercept is when y equals 0, so 5 over x plus 2 equals 0. -2 is 5 over x, so -2x is 5, and x is -5/2, which is -2.5, so it's going to cross right there. And so here is my graph. Now, that's all we talked about in the last lesson, but we want to add to that. What if I shift inside of the function? In other words, my f of x is equal to g of x plus or minus b. In this case, what I've done is I've got x minus 3. So I've shifted this horizontally. Remember, it's a little bit different than shifting up and down. In this case, it goes in the opposite direction because what I'm looking at is where is x minus 3 undefined at? X minus 3 equals 0, so x minus would be 3, and that would make this undefined. So my vertical asymptote is at x equals 3 this time. My horizontal asymptote would still be y equals 0 because no matter what I plug in for x, I cannot make that fraction equal to 0. And so now I will get my points. 5, 1 has been shifted. What did I say? 3 places to the right, so it becomes 8, 1. So 8, 1. And 1, 5 has been shifted 3 spaces to the right, so it becomes 4, 5. So over 1, 2, 3, 4, 1, 2, 3, 4, 5. And so this part of the graph is, I put 8, 0 instead of 8, 1, excuse me. This part of the graph has been shifted over there. We'll get our negative part, -5, -1, which was off of our original graph. Now gets moved 3 spaces to the right, so -2, -1. So -2, -1. And our -1, -5 gets shifted 3 spaces to the right, so that becomes +2, -5. So +2, 1, 2, 3, 4, 5. Now notice this time it's going to cross the y-axis, not the x-axis, because that's my asymptote again. But let's find where it crosses the y-axis. Crosses the y-axis where x is 0, so y would be 5 over 0 minus 3, which is -3. -5/3 is -1 2/3, so right along in there. And so here is what my graph would look like for that one. Okay, now I want to put those together for you. What if it does both? Well, we can look at this and we can see we have a horizontal asymptote at y equals 2. The 2 shifted it up. We have a vertical asymptote at x equals 3. The -3 shifted it to the right 3 spaces. So we've got a vertical asymptote here at x equals 3. We got a horizontal asymptote here at y equals 2. Now we could sort of sketch that in there if we wanted to, but let's get some exact points. Our 5, 1 being shifted to the right 3, 8 into the up 2, 3, so 8, 3. Our 1, 5 is being shifted 3 to the right, which is 4, and 2 up, which is 7. So 4, 5, 6, 7. So this part of our hyperbola is over here. Now to get our other part, -5, -1, going 3 to the right takes me to -2, and 2 up takes me to 1. So -2, 1. And -1, 5, -5, 3 to the right takes me to 2, and 2 up takes me to -3. So over 2, down 1, 2, 3. Notice this time it's going to cross both the x and the y axis, so let's solve those. Crossing my x-axis where y is 0. So when y is 0, I've got 5 over x minus 3 plus 2. So that becomes -2 is equal to 5 over x minus 3. So -2 times x minus 3 equals 5. -2x plus 6 equals 5. -2x equals -1. So x is going to be 1/2. So 1/2 on the x-axis. And now for the x to be 0 would give me on the y-axis. So y would be equal to 5 over -3 plus 2. That is -5 thirds plus 6 thirds, which is 1/3. So my y would be at 1/3, and so here is my graph. So that is shifting in 2 directions there. We will pick up on the next graph in other transformations.